All right, so I would expect that we hopefully know the 4 chambers of the heart, and perhaps it's 4 valves. Okay? So, if blood is returning from the rest of the body, okay? So here we can have this in front here. So as blood is returning from the rest of the body, it does so from up in the cranial area and from the abdomen through here. Okay? These 2 structures have the same name, just that one's above, one's below. So what vessel is this called? It is the vena cava. So then how do you know the difference then? Here's the superior vena cava, here's the inferior vena cava. So where is blood entering? See, I can cheat a little bit because I don't have to know left and right because the mirror image is on your side. That's what I mean I get to cheat a little bit. Or should I do it like this instead? Or is that silly? Yeah, it's silly. We'll just do it this way. Okay, so this chamber. You sure? Is the right or the left? Yeah, it is the right. Okay, so then what valve would be between here? What valve would this be? And maybe what we can do, and I think I only have 2 models for that. I'll be right back. So hopefully that makes a little more sense. We try to get those models in the middle of the room where we could actually see them. Okay, so we had the inferior and superior vena cava traveling through the right atrium, and that is which valve, you said? Tricuspid, okay? Then that means it's entering this chamber. The right ventricle, which then means, okay, it's going to exit through here. And I don't know if you can see that on, I think on them smaller models of the heart, I think they actually just come off. I think it's magnetically stuck together. So then this is which artery, first of all? It's the pulmonary artery, and then that makes this which valve then? Pulmonary semilunar valve. So then notice that this splits, and this is something that you can't see on a diagram. This is leaving for the left lung, this blue artery. And as we said, as the aorta comes out, the right pulmonary artery is actually underneath and is actually right here. Okay. So then blood is going to the lungs in which circuit? It's going to the lungs. Because remember, this is a double circulatory loop, so this is one loop. When it goes to the lungs, it's the pulmonary circuit. Gas exchange takes place, then it comes back to the heart through the left pulmonary vein, even though it's red. Here's the right pulmonary vein, even though it's red. Okay, so where's that emptying into when it comes back from the lungs? Yeah, left atrium. And you can actually see that here. I don't know, again, what your models look like, but you actually see here the pulmonary veins here. And you look inside, you can see where the right pulmonary veins are coming through, and it just leaves a couple of openings way up in here, and that's what this is illustrating on this side. So then it drains down through this valve into this chamber, which is what? The right, no, not the, oh, I thought you said right. Left ventricle. Then where's it leaving after, what valve is this? Bicuspid the left ventricle contracts and then pushes it through the, can't see it up in here, through the aortic semilunar valve. Okay, so this is one of the things we spent a little bit of time on earlier, or I should say last week. Okay, and your models don't quite stick out as far as these do. The reason we're spending so much time on this is because this is really kind of tricky here. You've got 3 branches off of the aortic arch here. The far outside is left something, because this is going all the way up into the brain. Okay? Then this, I made a mistake. That wasn't intentional. This is not the left common carotid. This is actually the left subclavian. Okay? Then this in the middle is your left common carotid. And then this actually sits on here. We'll just make it a little bit longer here. Maybe turn it on the side, put it over here. Is this the right common carotid? It's a trick question. It is not. Say that again. This is the brachiocephalic trunk. It probably isn't quite this long, but should stick out here a little further. Then this branches off. It's going to supply the arm by going in this direction. And what artery would that be? It's the same as this one. What did we say this was? Starts with an S. This is the left subclavian. The right subclavian is probably somewhere in this vicinity. And then this continues to supply the brain. And then there are 2 types of carotid arteries, not just the left and the right, but what's significant about those 2 carotid arteries? What are they called? And if you're at track, you would not know this unless you tuned into the Science Channel. And even if you were here or even tuned in, you might not remember. It is a lot to remember. One's inside, one's outside, but that's not what we call it. We don't call it the inside carotid artery or the outside carotid artery. There's a better terminology for it. Kind of like your oblique muscles. You have an internal carotid artery and an external, which reminds me, does anyone follow baseball in here? Because I heard this on the radio, and Minnesota's shortstop, I think, is on the injured reserve now, because this sometimes happens when batters maybe swing an off-speed pitch and they swing with such force that they actually pull a muscle in their trunk. Okay? Actually pulled an oblique muscle. So I presume it's probably his external oblique. So, but that does happen. So what I'm getting at is when you hear that, you say, oh, I know where that is. And maybe people around you say, how do you know where that's at? Where are your oblique muscles? They're not, I think people commonly think it's up in the chest, but it's not. Obliques are down in your abdominal area. That's right. So I'll go ahead and set this out here if we choose to look at that. Okay, then we left off with, where is my remote for this? Oh, it's right here, in plain sight. Well, I think the weather would be warm enough tomorrow for you students to be leaving in 24 hours and 10 minutes, but I think maybe the skies won't cooperate. Have you ever ran or run in, yeah, you ever ran in Alcester before? It's always not nice. Okay. Oh, but what's the track like? Not that any track's any better than the other, but maybe some are in better shape than others. Okay. All right. So this is where we left off with, and we might have even talked about this, but that's something that you can see in those models, and especially in that model that I was holding. So one of the aspects that we see, there's a reason why the atria are much smaller than the ventricles. Okay? So what would we mean by this bottom idea here? Workload. Even within the heart itself, who's got the biggest workload in the entire heart? And that would be correct. Why is that? So when we look at this, are these part of the pulmonary or the systemic circuit, the ventricles? It's a trick question. Why is that? Okay? Because when we said this is the largest of any of them, which it is, so is that the pulmonary or the systemic circuit? Which one? The left ventricle sends blood where? To the rest of the body. The right ventricle sends blood to where? To the lungs. So then the workload isn't quite as big in the right ventricle as it is the left, okay? Then when we look at these are the receivers. These send blood, even though we say that they receive it, well, so do the ventricles, but it's mainly just draining from the atria down into the ventricles. Okay. Man, is it working from all the way over here? Hey, this is working. Usually I ought to stand right next to it. All right. And we just went through this. This is just a written explanation of everything we just had mentioned. And this, we do want you to know. Put stars, underlines, whatever it is, when you need to describe the path of blood through the heart. Because it's not just chambers, it's also valves and vessels as well. And the reason for that is that the next time you see this, we want you to be prepared for it, whether it's 1 year from now, 2 years from now, or even 3 years, depending upon how your post-secondary classes go. I mean, you might not be taking this right away the second year of technical school or college. But we want you to be prepared and ready for these deep thinking concepts. can't remember if everyone was here when we gave this example, but when we're talking about this here, this valve, okay, the tricuspid we know is on the right side, and the bicuspid would be on the left. For our purposes that we had explained, why is possibly the bicuspid on the left side of the heart instead of the tricuspid? Wouldn't it make more sense to have more portions on the valve where the pressure is the highest? Does this conversation sound familiar? Yes? No? Okay. This is how we had explained it. It might have been on Thursday, but maybe it was on Wednesday. Okay? So if we're taking and looking at this from, oh boy, the juniors better be ready for these, shouldn't they? These fatty acids. Memorize them. Does this look intimidating? You too can say yes if you want. So which one is this? No, this is linoleic and this is linolenic. Yeah. Okay. We're talking about omega fatty acids. That's where you saw that. But I want to leave that up here. This is an omega-3. That's what that's supposed to mean. But okay. Anyway, as you're looking down from the top of the heart, okay, so we'll try to do this anatomically correct. This is the left side. This is the right side. Okay. Actually, it's probably okay. So tricuspid valve, bicuspid valve. Okay. We said that pressure, would it be higher for Brandon Valley or Tri-Valley? That just popped in my mind. Okay. The bicuspid valve or the tricuspid, where is pressure probably going to be the highest? Okay. And the reason for that is this is the left ventricle, and then this is the right ventricle. So, should that happen, and if this is a circumference of standing on a shallow creek bed or something to that effect, you can hear the ice cracking or something to that effect. Which one of these, if you're standing within this circle, is going to be possibly weaker and break first, where there's 2 fractures or possibly 3? Do you think? Okay, so to me, it looks like a weak point could be right here. So to me, I think, and for our purposes, we explain it in this fashion, and the pressure's higher here, it doesn't have as a big of a, let's say, a weakness like it would here, where there's 3 portions of the tricuspid valve come together. So that's how we want to look at it. It could be such a thing that 2 or 3 years from now, gosh, I remember talking about this in high school. He was wrong. Hopefully that doesn't happen. Hopefully we are preparing. All right, so back to this. And, okay. I just want to get through. We got structure of the heart today and tomorrow, and then heart action, so we're doing just fine. And I think you would serve, then once you put an R in here, then you might think that that's on the right side of the heart. But I think as long as you know it's the bicuspid valve, you should be fine. But some periodicals and maybe some anatomic professors Maybe we'll find out on Wednesday, April 24th. That's not too far away. That's when we're all heading up to Brookings to look at their anatomy lab. That maybe they refer to that as a bicuspid or mitral valve. And sometimes this happens a lot of times in science. Why is it given one name and then some people refer to it as another? I don't have an answer for that. In other words, since you two are in the splash zone here, so if I said methylbenzene here, you probably refer to as what instead? Toluene, that's right. So one of them is a scientific name, one of them is a common name, just like methylbenzene and toluene. They both mean the same thing. Okay, for this portion, that is where we will stop for today. But again, don't let this sneak up on you. Okay? What I mean is as follows. Does everyone have this content that wants it? Okay? See if I still have these loaded up. Okay? This is what we're talking about here. Okay? Don't wait until 1 or 2 days before we have an evaluation and then, oh gosh, I better look at these. Okay? Remember when we were talking about this earlier, okay? We had this diagram on here. Now maybe we could say this makes a little more sense when we see this. So if we put this right here, okay? On the right side, this is not, again, this isn't your carotid artery. It's what instead? It's a trunk. Because for some reason, just the way we're designed, this short portion is your brachiocephalic trunk. That's why that's pointing to there. Then we see that as that travels, it's supplying the rest of the arm. And that's your subclavian then. But then what we see here, and it's hard to see this in 2 dimensions, but just think of it this way. This individual or this model, whichever, is looking to the left. So if this face was to turn this way, okay, this would be further in back, and then this would be further to the exterior. If that's the case, if this is outside, what is this known as then? External carotid artery. Then we have the internal carotid artery right here. Which then means, which vessel is this then? It's the middle one here. Yeah, here you have a right common carotid, or even right external common carotid, and here you have a left external common carotid. And what's this vessel called? Starts with an S. It's going to be your subclavian. That's right. And then, for the most part, we try to make sense that every time that something branches off of there, like here and here, or right here, after we get past the brachiocephalic, this is the subclavian, and then turns into the axillary artery. And this would be the left axial artery. I mean, there's really no clear-cut definition to say, to make sense of that. We know that this is the femur. We could call it the femur here. We could call it the femur up there. So in a lot of cases, it really doesn't matter where you're pointing to that vessel. It just means that if there's something that has branched off of there, it probably has a different name. So then the most common name you could give this artery right here is what? Do you think? Your femoral artery. Then after that, what would this one possibly be? Notice it's tucking underneath of the femoral artery, which means it's going deeper into the tissue. So it gets its name from the femoral artery to then the deep femur. Okay? And it does something similar to up here in the arms. Okay? Anyway, we just want to spend a little bit of time on that, and then don't forget to look at this. Okay? Here's your brachiocephalic, your left common carotid, your left subclavian, your superior vena cava, okay? Inferior is down here, all the sort of chambers. Okay, I think that's enough. You can look at the models if you so choose. Otherwise, we will catch up to you next time.